Well, good morning, everybody. There's been a natural progression in the thought process over my last 3 or 4 videos here, as we discuss the implications of this fall drought, the building of La Nina, and what it might mean for, the upcoming 9 to 12 months. And remember, what we were doing here was, like I said, just highly speculative. We're just looking and trying to assess and make some sense out of what's going on. So what that brings me to is a good question I've been asked many times over the last, honestly, over the last 15 years. And it's been about drought and its potential for being cyclical in behavior. And what I mean by that is by cyclical, predictable. Okay, so if you can find a cycle, you can then predict the next peak in that cycle. And I've searched for that. I've spent a lot of my career looking for cyclical behavior in any sort of weather patterns beyond 2 weeks out into the subseasonal or seasonal. And it's been a very challenging thing to do. And oftentimes the relationships are so weak that we can't use them as predictors. And at other times you feel like you can see the future quite clearly. And this is a case where I just want to make a point about a question yesterday that was on the comments, because I get asked all the time. And it was about some research done by Dr. Elwin Taylor out of Iowa State. Brilliant man. I love everything that he has done. He's a pioneer in agriculture meteorology and have tremendous respect for him. But he did some work where he claims that there is this cyclical behavior in drought, and it's related to solar cycles. I thought we'd just talk about it. Looking at things, I wanted to start at the very basics. Okay, so I picked the big central U.S. region, and you know why I picked this area. This is the area that we're currently seeing significant drought in the United States. Now, that is not to leave out what's going on in the Northeast or any drought that's in the West. It's just been a focus on the central U.S., and that's where Dr. Taylor's research was as well. Now, if we look at a 9-month moving average of drought, which is what you've got down here at the bottom, going back to 1895, the first thing we want to do with data like this is just do some time series decomposition. Look for, periods of drought, and if they are on some sort of repeated time interval. So you can do Fourier transform analysis. You can do whatever kind of time series decomposition you want, and there's a whole bunch of them. And I've done them. And what I found is that there isn't a period to it. In other words, if you saw one every 11 years or something like that, then it would just keep lining up. But you notice that it doesn't. Each one of these spikes up is a period of drought. Each one of the spikes down is a wet time period. And so there doesn't seem to be any sort of cadence to it. And certainly the statistical analysis doesn't show that. In terms of being a reliable predictor, it doesn't show it either. We have long duration drought periods like the 1930s and the 1950s. We have, extreme short duration droughts like those in 1976, or like the one here in 1988, or the 2011-2012, which is right in through here. And at the same time, as you look at this, we have these extended time periods of extremely wet weather. And actually, over this whole time series, throughout this region, there has been an increase in the wetter time periods versus the drier time periods. Now, that's just a longer-term trend, and it's very weak. It's not something you can look at and go, oh, we're just going to get wetter forever. No, there are still, drought episodes, and we are questioning if there's a big one coming up. So the work that was done, which I want to remind you, this is important, okay? The work that Dr. Taylor did, he did publish on Iowa State's website. But it was not peer review published. And I think it's just important to say that. He did great work, and he analyzed tree rings. I've seen his presentation on it. He's also done, this relationship with what's called the Gleisberg cycle, which is a solar cycle event. But I don't know that he decided to put it through the peer review process. I can't find a peer review paper on it from him. So that's just something to consider as we go through this. Okay, we've been on this map forever. Let's take you over to the other part of his research. So we have data on solar cycles going back for a long time, all the way back to 1750s here. And it's in a very predictable rhythm. There's actually a few different cycles that overlay here. There are some big minimums, like the one you had in the early 1800s, and there are these maximum time periods. There is an 89-year kind of cadence to it. There's also a 22-year and 11-year. The 11-year is the most pronounced, as you can see here, which is the spikes up every 11 years. And so our sun goes through this regular interval of changing its convective behavior through the photosphere by producing sunspots. And we are in a peak right now, okay? And that peak is what's been causing a lot of the solar flare activity we've seen. So one of the great websites out there, it's just swpc.org. .noaa.gov, or just Google Space Weather Prediction Center, and it's where you can go to see the timing of the next aurora or the next big coronal mass ejections and things like that. It's a fantastic website. I use it all the time. You should as well. But just thinking this through, what it's focusing on is way down here at the end. And this is the natural 11-year cycle. We're going into solar cycle 25, which is in 2025. And it certainly reached a peak early. Will it continue to go and stay high? Yeah, I think it will, which means we might be seeing more of this solar activity with time. Now, let's just take you back to the whole data set. If this was directly correlated with drought, we would then go back and look at this time series, and these would overlay perfectly with these, right? But the correlation between sunspot behavior and episodes of drought is weak. And I've shown this in the past, but we'll show it again. I've been focusing a lot on next May to August, right? I'm trying to figure out how this drought we're currently in influences the next growing season. And Dr. Taylor's prediction was that 2025 was going to be a big drought year for the United States based off of cyclical behavior that he said he found in tree rings and in solar cycles. But the correlation, if you look at all of them, okay, so this is important to do. If you look at all of the solar cycle data against all of the historical precipitation data, the correlations are very weak. Now remember, when we're looking at these correlations, okay, let's just draw a line. So let's just say that this is sunspot cycle or solar activity, and this is precipitation. I can't write very well this morning. There we go. What we would want, if we were going to use it as a predictor, is that every episode, it's hard for me to draw this here, but they would all line up on a line like this. In other words, if you look at every year and made a dot for it, they would all cluster tightly around a one-to-one line, meaning that we could predict increased sunspot cycle, increased precipitation event risk, be it drought or flood, whatever, it doesn't matter. But what we find here is that the correlations are really weak. Okay, do you see what the values are? They're somewhere between 0.2 and negative 0.2, meaning that the spread is so large that it's not a good predictor. And I want to just tell you something that I know about drought. Okay, there's two important things you need to know about drought. The first is simply this. Drought episodes are almost always the combination of a sequence of events that constructively add together to lead toward the shutting off of rainfall. Do you remember how we just talked about the drought this past fall? What happened? The atmosphere lost momentum. We built a large ridge that extended from the southwestern United States up into eastern Canada. The atmospheric momentum backed off. We saw deep lows forming in the Bering Sea and in the Gulf of Alaska, never making it to the U.S. The MJO switched all the way around to the Indian Ocean and then over toward toward what we call the maritime tropical. That would be near Australia, We watched La Nina build. We saw tropical events that happened in all of those things took the flow away from the central U.S. And I know I've left you on a couple of maps for a long time. I'm sorry about that, but I'm just trying to explain this. And then here's the other thing. I have learned in my professional career that drought never breaks gently. It doesn't just break on a simple little rainfall event. It doesn't break on a sequence of them. It tends to break on huge events. So here's what we're going to do. I'm going to go back and I'm going to look again at that time period, May to August. Go back to 1950. Now, the reason I go back this far is because that's when two of our major reanalysis data sets were begun. So this is how we look at historical weather. And I made a list. I sorted all of them. Driest central United States, 12, 88, 76. You can see the big years here. And I went back and I said, what is the sequence of events that we have to watch for? And it's right here. Okay? May to August, if next year's going to be a drought, we will have what I call the triple ridge pattern. The Bermuda High, which should be here, tends to move. We tend to build large areas of high pressure in the northern plains. And there tends to be extended areas of high pressure here. So the jet stream comes diving over the top of this, rolls up into Canada, dives into the northeast and Canadian Maritimes, then goes into Europe. And that is a pattern that robs momentum from the atmosphere. You build high pressure in those months. You don't get the precipitation. Why? Because the flow comes around the high like this, blocking the Gulf of Mexico. So where's it wet? The southeast, the south, the Rocky Mountains. Like that's where it's wet in this pattern. It's wet on the west coast. And when that occurs, we typically look for a couple of precursor events, like very warm water north and west of Hawaii, and very cold water here in the Gulf of Alaska, in our PMM region, which is there, and La Nina. So you now know that I'm watching this, right? This is our first ingredient, checking the boxes. It's really dry now. And if this is still here in spring, we have got a serious issue. And then the second thing, which I just based off this analysis, is this. So now you know why I'm watching this. If that warm water continues to migrate and grow here while this colder water begins to overtake this whole region, that's the PMM region, and then we get this all showing up cool, those are all ingredients that just lead naturally toward drought risk into the next year. And so what I'm just going to say, and this is just me, by the way, what I'm telling you right now, I didn't publish either. I'm putting it into a YouTube video, so please understand that. But the work that I've done on the side, which I've presented all over the country, basically says that these solar cycles are not as strongly correlated with weather, but could they be a component? Right? What did I tell you? It's a sequence of events. So could a peak in a solar cycle plus a fall drought plus a building of a La Nina go in to steal the momentum from the atmosphere and give us a shifting bulge of heat toward Hawaii, which promotes this and work against next year's precipitation patterns? My answer to that is yes. And I'm just going to tell it to you like this because I want to be very transparent. I am not saying this for any other reason, just because I have a scientific interest in it. That's it. So I'm not telling you this because I want you to be out there changing your market positions or to start to raise some hype about next year's drought, because I'm going to tell you something really simple. Next spring could come along super wet, unpredicted, very poorly predicted, erase all of this, or we could get just-in-time rains in June, July, and August, like those just thunderstorms that hit at the right time, and it doesn't even matter what I said now, okay? So I'm going to be very clear about that. But the reality is that this is how October shaped up so far. Forgive me. And outside of the low that curled up this past weekend and moved across the central United States in the last 3 days, we've had Milton, and that's it. It's been a very, very, very dry October month to date, and numerous places are having 132 out of 132, meaning it's the driest they've measured for an October since 1893. Over the last 10 days, this is it. We've had systems that have hit the Northwest, but they've mainly hit British Columbia. We had the cutoff low here that spread some rain. I got 600ths of an inch at my house. I put a dot, of course, for my house because I make the maps, right? We had some moisture that got through the Great Lakes states into the Northeast, but that's been about it. And this morning, let's get an update on this. We are watching some moisture move through the Great Lakes. Here it is. And some right here on the South Dakota-Nebraska border. And this is moving into Ontario and Quebec, and that's about it for right now. So much of us in the middle of this huge drought, we're waiting on this guy right here. There is a shortwave trough that left Siberia yesterday, and it's right there. And there's a cutoff low that is way off the coast of California that is here. And these two events are expected to combine into a deep low that's going to initialize itself here and then move across the United States and finally give us that southwest flow that we know is critical to deliver moisture to the west coast, the central United States, and eventually up toward the east. Now, the place that misses out on this the most is the southeastern part of the United States. But if you're curious what all the hope is in right now, it's this guy right here combining with this. And this is our Halloween week storm system. So let me show it to you. These are winds in the upper levels of the atmosphere. You can even see the first part, but here's the second part. When does it come into view? Right there. There it is, coming right over the Aleutian Islands. When are we? We're on Thursday. Now on Thursday, there's another weak little wave right here moving through the country. It's a small one, a short wave, a very small short wave. And it's going to increase the chances for late week precipitation in the Corn Belt before it moves off to the north and east. But watch these two right here. This is Thursday, Friday. See how they come together? The lead wave gets knocked out here. The deeper one that came from Siberia is now very deep. So we need to see on Saturday this huge low just rumbling its way through the Gulf of Alaska. And if that's there, and the models are right, we got another step closer to this. comes into the west coast. You're going, where the heck did it? It's still here. Came into the west coast, and now by Sunday, we're increasing the pattern to give us flow like that. So here is our high pressure cell over the southeast. Here's the low that came in to the northwest. And watch. It emerges, curls up, reinvigorates over the Rockies, ridges in place, low-level jet forms, upper-level jet forms. The whole thing comes cranking through the middle. And when is it? It's Monday, October 28th. And it comes racing through, and it's followed up by a second system around Halloween. And the jet stream pattern is just cranking this through here. So we need to see what this is going to do. So remember, that is all late next week. So all of these maps, which are on agweather.com, which show you the next 7 days, they don't even really have it except for what's going on in the northwest. In fact, if we zoom in on the WPC, this is the beginning of the system. Forgive me there. This is just the beginning of it. This is coming with a system that's going to go over Idaho very soon and then get into the Midwest by the end of the week. And this is what, we're still watching in the Canadian Maritimes back toward Ontario. The driest spot in this forecast is here. So let's walk through it, kind of figure out how this is all going to go. And we're going to start off with today's all hazards weather map. Still pretty, uneventful. Major frost freeze event going on right now in parts of the Willamette Valley down the I-5 corridor. And outside of that, some air quality issues down here along the Gulf Coast and into the Northeast, where we've had several wildfires lately. They've been small, but there have been fires in the Northeast. Looking at the high-resolution NAM simulation, this is going to start off. There we go. Let's get it queued up to this morning. Just play it forward. There's the wave that comes into Oregon. When? This will be Wednesday night. I'm actually going to California this morning. And just a quick announcement. I apologize. I should have said this at the beginning. I'm going to go to California today. I have an event near Fresno. I won't do the next 2 morning videos. My travel schedule is a bit weird. I'm going to red-eye home, and therefore I won't have the ability to record for you. But my colleagues Matt and Andrew will fill in. Anyway, here comes the wave through Idaho. It goes right through the northern plains. It builds into a little bit better front through parts of Wisconsin, Minnesota, Iowa, Missouri, possibly back into this part of Kansas. In the overnight hours on Thursday, sweeps through on Friday, and it's kind of absorbed into the flow here, giving the rainfall event I mentioned a moment ago in Ontario and Quebec. Okay, beyond that, let's get queued up with the European model. So there's that system. There it is coming through. Not a major rain producer, but it's going to be producing some in the Midwest, which has been dry after starting in Oregon and Idaho, moving across. But what we're watching as that system curls up, there's the moisture that's coming in Ontario, Quebec. Frontal boundary lingers to the south of it through parts of the mid-south, but all the action's going back here. So here we are on Sunday. This is when the deep low is just off my map. We're going to watch it curl up. There it comes into the northwest. When is that? That's Sunday into Monday. It then builds itself into a deep low that's way up here in Saskatchewan. But all of this is tight pressure gradient. The ridge moves off to the east. We open up the Gulf of Mexico. And on Monday night, getting into Tuesday and Wednesday, can you see it? That system rolls up into the Hudson Bay here. High pressure builds in, and all around the periphery, we're going to be lifting that air. So this is this kind of system that goes through, and then the pre-Halloween heavy rainfall event. And what it's actually doing is it's just squeezing the atmosphere on the tail end of a front connected with this low, but there's high pressure on the backside and high pressure on the front side. So in the middle is where we're expecting that rainfall. Again, this is mid to late week next week, and that rolls through. But could it start a better pattern for October? For November, I do think there is the case that it could do that. And by the way, as this comes in, it's got snow in it. Let's refresh that real quick. There we go. Take a look at the snow in the western U.S. as this system comes in. There's Sunday, Monday, Tuesday, Wednesday. Now, some of the snow chances in the northern plains have been taken out by the current European model, but we're going to add up a lot in the Cascades, the northern and central Rockies with this. Wind speeds. I like the GFS forecast of the wind speeds. It tends to do a better job in my opinion, but we're looking out there next Tuesday, Wednesday, Monday, Tuesday, Wednesday. Look at this wind event in the central plains. Very, very strong. And by the way, the models keep flip-flopping back and forth on there being some weird tropical system down here, but don't put too much hope in it just yet. But we're looking at some very strong winds forming in the next 10 days in the central U.S., coming out of the Four Corner states, getting all the way into parts of, eastern Canada. Where are the winds going to be weakest? It'll be down here in the southeast. So probability-wise, best chance of getting a ½ inch over the next 10 days. That's what I've got. So that system enters, curls up, frontal boundaries left in place, better chances for a multi-day rain event here. Here's the probability of getting an inch. So we're looking at right in the heart of this drought area, you know, a chance of 50% to 70% of getting an inch out of this. And our drier spots, if we flip over to the chance of staying under a ½ inch, is primarily the southeast and east coast, Montana into southern Canadian Prairie, in the southwest, because the flow's not dipping down here yet. Now, the week 2 forecasts, they're capturing this because all these maps start next Wednesday. So you can see they're getting that event, and they've all got it kind of in place with, again, the same pattern we just discussed. So again, you can go to agweather.com and get these anytime you want. All right, temperatures, then we'll look out again long range and be done. This is the next 7 days of frost. Again, this map is very similar to this every chance I've showed it to you. We have today's high temperatures. Tomorrow, major warm up in the southern plains, hot, like summer hot. Then Friday, remember that's the first front that comes through. And then we get the rebound in temperatures behind it, Sunday into Monday, while the East Coast cools off late this weekend. And then here it is. That's the low coming in next week. So you can see it really dropping the temperatures off throughout the west, the buildup of the heat here. And if you look over the next 5 days, okay, we saw that. But look at day 5 through 10. Major warm up, super windy, but then the quick crash behind it. So, other things going on. MJO is making a big move, 6, 7, and 8. I think that's part of a shift overall happening in the Pacific that's still giving us this idea that we have to be concerned about the risk of better rising motion ending up back in the Atlantic. In the next 10 days, I don't see it. This is what's left of Oscar, We do have some better chances of developing some sort of tropical depression down here, but I still don't see a major tropical event until we get to the very end of October, beginning of November, but we have to be on the lookout for that. So we just get out here to the longer range. That's the newest update from the European model, through the month of November. And I look at this and there is one surprising thing about it. And what's surprising is, why are we seeing wet conditions here in November and not seeing them along the west coast? And you're going, all right, well, the thought process is that if you can get flow to come through the west, it'll eject into the central U.S. And during the cold season, so November through, really through April, it's difficult to get, a dry west coast and a wet central U.S. Now, in summer, we can do it anytime you want. But you have to have the flow entering somewhere. So I'm a bit confused on that. I'll have to look into it more. But if I had to pick a spot that I thought would be the driest going forward, compared to averages, compared to their averages, it'd be the southeast. All right, so that's my newest update on November. I like the European model. It did extremely well picking up on this fall drought, right? Remember that from months ago? It did it. It found it. And so I'm going to continue to trust it because it seems to be picking up on the right signals. Lastly, I just want to show you some stuff on South America. Last 30 days of precip, we started to fill in some holes. There's been better moisture coming back. Remember, 50 millimeters is 2 inches, so we've seen that come through here. We even watched over the last couple of days pretty deep convection. I mean, you can see here, this is normal monsoonal behavior. Next 10 days, according to the high-resolution European model, is here. If you compare that to averages, it's only dry coming out of Paraguay to southern Brazil, quite wet here, very dry north in the Amazon. Also in Drought up here, but the GFS has that as well. That's the GFS 10-day, and there's the GFS precip anomaly. So they're very well aligned with these two epicenters of dryness with a lot of wet weather in between. So we'll just continue to watch these patterns evolve in South America, but this is going to allow for more planting. We're going to keep an eye out for any sort of drought pressure or flooding pressure in Brazil going forward over the next 3 months. We'll just keep you updated on that as we go forward. Okay, that will complete my narrative for this week. Again, I want to thank Andrew and Matt for filling in for me tomorrow and the next day while I'm traveling for work, and we'll get back into regular cadence soon. I appreciate it. Thanks.